I'm Anil Kumar, and here is another trigonometric equation from my test paper. The equation is sine x plus 2 cos x minus 1 equals to 0, where x is between 0 to 2 pi. Now, those of you who are working with degrees, they could do from 0 degrees to 360 degrees, right? So, you could solve in that domain also. Now, in this particular equation, what you observe is that we have two different trigonometric ratios. Now, solving one equation with two kinds of variables is kind of difficult. So, what should we do? What we can do is we can take a few terms on the other side, isolate one of the variables. So, one of them is sine. So, let's say sine x equals to, let's take this on the right side. So, get 1 minus 2 cos x, right? So, we get 1 minus 2 cos x. Now we can square both sides, right? So if I square both sides, I get sine square x is equals to 1 minus 2 cos x whole square, right? Now sine square x can be written as 1 minus cos square x. So that gives us equation in one particular ratio, which is cos, right? So let's expand this. We get 1 minus 2 times this, that means 4 cos x, plus square of this term, which is 4 cos square x. Okay, so that is what you get. Now you can bring all the terms together and then simplify. So we get 0 equals to, we'll take 1 on this side, so it becomes minus 1 plus cos square x, and we'll open this bracket. We have plus 1 minus 4 cos x plus 4 cos square x. Combine the like terms. So we have 0 equals to 5 cos square x minus 4 cos x minus 1 plus 1 is 0. So now we can factor cos x here. So we have cos x and we get 5 cos x minus 4. So that is what we get as equal to 0, right? Now we can solve for cosine x. But remember one thing, in between we squared, right? So squaring both sides, that now we square, right? So let me write square both sides. Now whenever you do that, it may result into errors. Simply because you do make minus 1 square as plus 1. That is an error, right? Minus 1 is minus 1. But however, when you square, you make it plus 1. So that results into few errors. So when you get the solutions, you have to check your answers so that they satisfy the original equation. So that is kind of important. So let us find out solutions for this equation. So one is, when is cos x 0? So we have cos x equals to 0. That gives you within this domain of 0 to 360 degrees as, or 0 to 2 pi. Let's write down for 0 to 2 pi, it is pi by 2 and 3 pi by 2, right? As far as the other part is concerned, we have 5 cos x equals to 4, or we could say cos x equals to 4 over 5, right? So that means we could have solutions in two quadrants. It's positive value, so we could have solutions in quadrant 1 or in quadrant 4. So let's find the acute angle for 4 over 5. So shift cos inverse 4 divided by 5 within brackets is equals to 36.86. So one of the solutions for us is this angle is, let us say, 36.9, right? So we have cos x as equal to, we say x equals to 36.9 degrees, or we have the other angle, which is 360 minus 36.9. Well, my calculator was in degrees, so I got that answer. I should actually change it, right? So let me change this to radians. Okay, so 4. Okay, let's do it again and see what is the answer. Okay, so we'll do shift cos inverse 4 divided by 5, and what we get is 0.64. So let me write down in radians. Okay, 0.64 in radians. Is that okay? So that is one. The other will be 2 pi minus 0.64. So the other answer will be 2 pi, so it is 2 times, let's say 3.14, or we can do 2 times pi minus 0.64. That gives us the other answer is 5.64. So these are the two solutions for us as far as the x value is concerned from the second factor, right? So we have possible 4 different solutions, right? So 1, 2, 3, and 4. What you need to do is substitute this here. So when you substitute pi by 2, so sine of pi by 2 is 1 and cos is 0, so that works, right? So that works. However, when you substitute, this is 3 pi by 2, I wrote it wrong. So when you substitute 3 pi by 2, sine of 3 pi by 2 is negative 1, correct? So when you substitute 3 pi by 2, sine curve is kind of like this. Let me sketch a small one here, right? Sine curve like this, right? So when I substitute 3 pi by 2, we get negative 1, right? So negative 1 and negative 1 makes it negative 2, not 0. So this is not the right solution, right? So that is what you have to take care of, right? Now similarly, in quadrant 4, if I substitute 5.64 in quadrant 4, sine will give me not the value of 1, but it will be, so not the value of 4 over 5 positive, right? We need positive, but it will give me negative. Let us calculate this, right? So we have sine of 5.64, and we know plus, we can write plus 2 times cos of 5.64 minus 1 equals 2. So we get very close to 0, very close to 0. That will work because we have done some approximations, correct? So that works. If I use 0.64, then we get sine of 0.64 plus 2 times cos of 0.64 minus 1 equals to, that is 1.2, right? So that does not work for you. So that does not work for you, right? So what you see here is that some values don't work. Reason is very simple. You square it, right? That is why they don't work. Now write down your answer. So we say our answer is all those values which worked, which is pi by 2 radians and 5.64 radians, right? You need not write radian. It's a ratio, but it's good to write, okay? So that is how you have to solve these questions, and take care that when you square, you cause errors, and those should be taken care of when you write answer. Thank you, and all the best.